Hello there. Okay, well, I think we got the hello there, right? Okay, so what are we doing today? We're completing this square. So, like, we should get some squares, right? Yeah, I definitely think so. So, let's just quickly get ourselves some basic things. If I've got a square and the area is 16, what are the side lengths of that square? Well, 4 and 4, right? Because 4 times 4 is 16. If I've got a square and the area is x squared, what are the side lengths of that square? Well, it must be x and x, because x times x is x squared. Okay, and maybe one last one. Rectangle of some kind. The area is 2x, and the one side is x. What should the other side be? Well, it should be 2, because 2 times x is 2x. Okay, so there's our basis. Now, we're going to do this with a picture for the first one, just because it's a nice way to kind of think of completing the square. So we are going to draw a square, but I'm not going to draw a complete square because, we're completing the square, right? So here's our square, but we're missing a chunk here on the bottom. This bottom bit we're missing. Now this area that we've got here, that's shaded in. This is what this represents here, the shaded part. And we're going to complete this square, this last little bit here. And therefore, we're going to need to subtract that once we've got our square. So let's see what we mean by that, right? So maybe just mini pause. So this yellow bit that's highlighted in the kind of this bit here is our bit here. So let's put some things in. So let's rub, not all of that. Let's rub these things out so we can see what's happening. So let's say that this part here is x squared, this little square. What are the side lengths of this? Well, x and x, right? That's like the one we looked up here. X times x is x squared. So this is x, this bit down here is x as well. That side length, that little length, that little length, that little length. Okay, and we've got two squares left here. And their area needs to add up to 2x. This one and this one. So what must the area of each of those squares be? Well, if each one is x, then we've got x squared plus x, which is x squared plus 2x. Cool. So that area matches that. Now the question is, this part on the bottom right, what is its area? Well, we need to work out what these two sides are. If we know what this is and this is, we can just multiply them together. So in other words, we need to know what that is and what that is. So let's look at this. This area is x. This side is x. So what must this little side length here be? Well, it should be 1, shouldn't it? Because if that is 1, then x times 1 gives us x. Well, if that was 1, well, x times 1 gives us x. So in other words, all these question marks are just 1. Cool. 1, 1, 1. So what's the area of this little square? Well, it's 1, because it's 1 times 1 is 1. So let's see what we've got here. We've said that x squared plus 2x is the same as this big square minus this little square here. So let's just see what we mean by that. X squared plus 2x is the same as the big square, x plus 1 squared. But we need to subtract this extra little square here, subtracting 1. Well, let's do one more example with the picture, and then we'll see how this helps us. So x squared plus 6x. Let's draw a square that is incomplete, because we're going to complete it ourselves now. This area is the same as this expression. So the first part, this x squared, we're going to write over here, x squared. So what are these little side lengths here? Well, they're x and they're x. Okay, what's left, let's do in this purpley, is 6x. So these two squares need to add up to 6x. So therefore, what is the area of each of those little squares? 3x and 3x. X squared plus 3x is x squared plus 6x. But if we want to complete our square by doing this little square here, we need to work out what the side length is and what this area is. So what we're trying to work out is x squared plus 6x. That's what this part here is the same as, it's going to be equal to the area of this big square. But we're going to subtract this little square here. So it's the big square minus the little square. So the area of the big square, what's this side length here? Well, x times something gives us 3x. X times 3 gives us 3x. So this is 3. So this is x plus 3. And I'm going to kind of just finish this off because if the picture bit doesn't fully make sense, I mean, that's fine in terms of what you need to be able to do, but it is cool if you can try and make sense of it. And our last bit, 3 times 3, gives us this area, which is 9. So the area of the whole big square is x plus 3 squared, but we've double counted this 9, or not double counted, we've counted it, so we need to subtract it. So there it is. Okay, now here's the bit to maybe take note of, so we can just do this with the numbers. So pause. If we want to actually work out what this is, just go from this to this, just the algebra, forget the picture. X squared plus 6x, and I say complete the square. Look at the 6. Look at the 3. How do you think we get from 6 to 3? Well, you might have said minus 3, or you might have said divide by 2. Let's check which one's going to work for both of these. How do we get from the 2 to the 1? Well, we subtracted 1 maybe, but we divided by 2. So to get this part here, we're going to take this coefficient of x and divide it by 2. How do we get from this 1 to this 1? In the same way that we can get from this 3 to this 9. Well, isn't it just squared, right? Square, completing the square. So to complete the square, we're going to take this middle number, divide it by 2 for this one, and we're going to square that for that part there. So let's just throw another one, any one. X squared plus, what do we want? 8x equals something squared minus something. X, because x squared. We're going to take this number, divide it by 2, so what do we get? We get 4. So we've got x plus 4. This number here that we need to subtract is this number squared. So it's 16. Let's just check that that works. Equals x plus 4 squared is x squared plus 8x plus 16 minus 16 equals, hey look, 16 minus 16, x squared plus 8x. And you might be asking why we need this, and that'll come in a second. Let's go to that why we need it. So how does this help us? Let's say you're given this equation here. X squared plus 2x equals 24. And I suggest to you that you solve it by completing the square, instead of just rearranging it. So let's go through it. X squared plus 2x equals 24. We're going to complete the square. So we've got x squared plus 2x equals 24. Let's complete the square. We're going to take this, we said, and we're going to divide it by 2 to get what's inside the bracket. So we got x plus this divided by 2 is 1. That's squared. Okay. And what do we need to subtract? Well, we need to subtract 1 squared. So we're going to subtract 1 squared equals 24. Well, 1 squared is just 1. But so there's what we need to do. And now we can solve it a bit easier because we've got x plus 1 squared equals Well, let's add 1 to each side, 25. Let's take the square root because that's what we were doing yesterday. X plus 1 equals minus 5. Or x plus 1 equals 5. So x equals, what are our two solutions? Well, minus 5 minus 1 is minus 6. Or x equals 4. So there were our two solutions. Felt a little bit convoluted to start with, but it will get us there. Okay, two more examples. X squared plus 6x equals 1. There's no ways you can factorize this with integers. There's no ways you can easily factorize it, rearrange and factorize. So let's complete the square step by step. We want this to be something squared and compensate for it. So x squared, there's where our x comes from. Cool so far. This is 6x. So we said we're going to take that and we're going to divide it by 2. So 6 divided by 2 gives us what? Well, it gives us 3. So plus 3. Now we need to subtract something. Let's take this number and square it. What's 3 squared? 9. There we go. We've completed the square. So how would you solve it from here? Well, x plus 3 squared equals 1. That's plus 9 on each side. And therefore we've got 1 plus 9 is 10. Let's square root each side. So x plus 3 equals square root 10. Or x plus 3 equals minus square root 10. Okay, so x equals square root 10 minus 3. Or x equals minus square root 10 minus 3. So definitely, I mean, when we start seeing surds, it's probably helped us. So as the last one that we're going to do very quickly. If we've got 4x squared minus 8x equals 12. If we've got a coefficient for the x squared, divide through by 4. So let's take that, divide by 4, divide by 4. So we've got x squared minus 2x equals 3. So that we've just got the x squared. So that when we do our completing the square, we know that this first part's x. Going to be easy at this stage. And then we take this number. Minus 2 divided by 2, minus 1. Minus 1 squared, or 1 squared, is 1. So that's what we need to subtract. Okay, so there's our completing the square. X minus 1 squared equals 3 plus 1. Well, 3 plus 1, I think we can just write as 4. So x minus 1 equals square root 4. Or x minus 1 equals negative square root 4. So x equals 3 or x equals minus 2 plus 1. Right? Yeah, minus 2 plus 1, minus 1. So our strategy in doing this is we just want to get from this step to this step. X squared x. Minus 2x divided by 2 minus 1. Subtract that 1 squared. That's our strategy. That's it. But the other stuff was interesting to see at least.